Okay, so we've got this question here. This is what we're going to work on today. I was just explaining to the students who are in the room what we're doing today, and what we're doing today is we're just going to work on this question and then have a work period. So if you're watching the video, all you have to do is watch this, or sorry, work on this problem. And I think I can just, what I'm going to do, I'm going to take a little snapshot of this. So take a screenshot. Okay, that looks good. I'm going to copy it. And I shall paste it. Oh, that's not it. Grade 12. Here we go. And okay, I should have done this beforehand. Anyways, there we go. And that's where I want to be. Excellent. Perfect. Okay, so we're going to work on this problem here. Question 9. This is question 9 from our book. This is from chapter 1.1, or I guess I should call it section 1.1, number 9. Okay. Okay, so let's just jump right into it. So I've got the graph of the function y equals x squared, and it's been translated 4 units to the left and 5 units up to form the transformed function y equals g of x. Okay, so g of x is our new function. We didn't really name the first function. I think it might be useful to us if we just go ahead and name this. So I'm gonna say that this one is gonna be f of x. F of x is equal to x squared. I think it's just going to be helpful to us if we can actually name it and call it something. So our first function is f, and it describes just the standard parabola with a vertex at the origin and no stretch at all. Okay, so it's just the regular y equals x squared. And then we go ahead and we translate that 4 units to the left and 5 units up to form the transformed function y equals g of x. Okay, so we want to find, first of all, the equation of the function y equals g of x. So if you were able to watch the video yesterday, you'll know just what to do. So the idea is that we're just translating this function. So the idea being that if we translate translation 4 units, what is it, 4 units to the left? Yeah, 4 units. I'm just going to write the arrow left. And what is it, 5 units up? 5 units up means that our function g of x, and this is why I wanted to name the first function f of x. Sometimes it's just easier to refer to things if you name it. Is going to be, well, what we're going to do is we're going to take our f, and to shift over by 4 units to the left, it's like, it's a common mistake to say, okay, well, going left is like negative, so I'm going to subtract. But we are going to actually be adding, because what the idea is that we want to subtract the number of values that we're going to the right. But in this case, we're going to the left, so we'll be using a negative. So we're going to have f of x plus 4, and then we are going to add 5 units at the end of it. So we'll have f of x plus 4 plus 5. Okay, so that's how we shift these things over. Okay, so all I have to do now is plug these values into my original function, and I know that f of x is x squared. So remembering that if f of x is x squared, let's go ahead and just write that right on the side here. So I know that f of x is equal to x squared. So knowing that, I can say, well, this is going to be f of, well, if I'm have f of x plus 4, I guess I don't have to write this anymore. I'm going to have x plus 4 squared, because that's what f does, is it takes its input and it squares it, right? So if our input is x, then then the output is x squared. If my input is x plus 4, then my output is x plus 4 squared. F is a function that squares whatever you put into it, right? So this is my this is what happens in that first part, f of x plus 4. Don't forget that we have to add 5 to the end of it. So we have plus 5. Now, the question doesn't tell us that we have to simplify our work. So at this point, for for all intents and purposes, we're done. We're done this first part of the question. So we've determined the equation of the function y equals g of x. So I might even want to, I mean, if I really wanted to, I could say that the equation is going to be y is equal to x plus 4 squared plus 5. So there's my equation, which is because this part right here is g of x, and yeah. So what I'd like to do just really quickly, I'd like to just head over to Desmos just for a minute, and let's go ahead and graph these things. So let's go ahead and do that. So I'm going to start off by saying this is f of x. I'm going to start off with f of x, which is going to be x squared. Okay, so there's my function. I know it's a little bit hard to see. Maybe what I'll do is I'll put it on projector mode, so it increases the font. Can you see that okay? Is that visible? Okay. So there we go. We got f of x is x squared, and let's see what else we have. Okay, so I'm going to go ahead and I'm going to write down kind of what I had over here. So I'm gonna just punch that into Desmos and see what happens to it. Except I'm gonna use some sliders. So I'm gonna write f of x plus h plus k, and I'm gonna add these sliders. Okay. And actually, I'm going to have f of x minus h, okay? Because we are subtracting. We always want to subtract the horizontal translation. It works a little bit backwards. I talked a little bit about that in yesterday's class. Let me just go full screen here. I talked about that in yesterday's class. So if you're a little confused about why that is, feel free to visit yesterday's class. So let's go over here. I'm just going to make the sliders go a little bit smaller just so I have more resolution. Okay, so you can see here that if I want to shift my graph over like by a factor of 3 units here, then h can be -3 here. So you can see that we actually really are subtracting. We're subtracting whatever we want to shift over. So if I want to shift over -3 units, like 3 units to the left, well, then I'm going to subtract that -h, okay? And if k is equal to 1, right, k is the value that we're adding on to it, then that means I've shifted my function over by k units. So if both of these are 0, right, close enough to 0, then you can see that we're actually just right on top of the function, okay? Maybe what I'll do is I'll make the steps just by 1. That way it's not so sensitive. There we go. So yeah, you can see that as I move this value up and down, the k value goes up and down. Remember, that's what I'm adding outside of the function. Then my function goes up and down. And then as I move h around, so if h becomes positive, then I move to the right. But remember that h is a value that I'm subtracting inside the function. And like I said, if you don't really see why this would be, then I just refer you to yesterday's video. So so now I know that what I wanted to, what was it? It was going left 4 units and up by 5 units. Was that right? Let me just verify that. Hold on 1 second. Okay, 12. And yeah, I wanted to go left 4 units, up 5 units. So I ended up taking f of x, was it x plus 4, f of x plus 4 plus 5. Okay, and you can see that goes right on top of the function that I just sort of constructed using those sliders. So it's that same function. Beautiful. Okay, let's head over. And by the way, that's going to be this function, fx plus 4 squared plus 5. So there it is. I've constructed it in 5 different ways. And it's and plus 5 f of x. Oopsies. And there it is. So there's that function that we just wrote. Okay, and there's the original one. Okay, so that's part A. Let's go on to the next part of the question. So what are the domain and the range of the image function? Okay, let's think about what that means. Okay, image. What do we mean by image? That's not really a term that we looked at too closely yesterday. So if I have a value, so here let's say that this is my function f, and I want to put a value into x, or sorry, a value x into f, and then f outputs a value which we call f of x. So this is the input. This is the output. Okay. Another way that we can call the output, another word for the output is, we can say that this is the image of x under f. Okay, so that's another way we can refer to the output of a value when we're with respect to a function. Okay, we can call it the image. Okay, it's the image. Kind of like how you can have something in real life and a camera will take a picture of it and the output will be the image of that thing. Okay. So what are the domain and the range of the image function? So the image function is going to be, in this case, g of x. G of x. Okay, so let's think about the domain and range of g of x. So the domain and range of g of x, well, let's think about what this is. Remember that g of x is going to be x plus 4 squared plus 5. Okay. So remember that the domain is all the values that we're allowed to use for x, right? Is there any number that we're not allowed to add 4 with? Or can we add 4 to any number? Yeah, we can add 4 to anything, right? You can add 4 to the number 6, you can add 4 to the number -6. You can add 4 to anything you want. Okay? In addition to that, you can square any number. You can square positive numbers, you can square negative numbers. There aren't any restrictions on adding numbers, squaring numbers, and then adding numbers again. So the domain here, we don't have to worry about anything. The domain is the set of real numbers. So all real numbers will work. Another way of stating this is that the domain is the interval from negative infinity to positive infinity. And we use round brackets, of course, when we state or when we use the values positive and negative infinity, because they're not actually values. They're not actually numbers. Okay, those are I like to refer to them as directions, like left and right. Okay, so so that would be the domain here. Let's talk about the range. Let's talk about the range. So the range, let's do that over here. Okay, so the range is going to be all of the y values that we use. Okay, so let's think about that. So I think that the smallest number that we could have here, the smallest number that we could possibly get out of this is going to be 0. Okay, like if x was equal to -4, okay, then I could turn this set of brackets into 0. Okay, so if x was -4, I would have -4 plus 4, which would be 0. So I would have 0 squared. So that's the smallest number that I could get. If x was like -5, for example, if x was -5, then this all of a sudden would become -1, but then I would square it to become +1, right? So the smallest thing that I can get out of this square would be 0. But then whatever I get out of this, I'm going to add 5 to it. So the smallest number that I could possibly get is +5. And that happens exactly when x is equal to -4. So when x equals -4, g of x is going to be, well, -4 plus 4, which is 0. So 0 squared plus 5. So I would get 5. So the smallest number I can get is 5, and I do actually get 5, right? I touch 5. It's not like I approach it. I actually do get 5. And there's no limit. There's no limit to the maximum value that I get. So I go all the way from 5 to infinity. And just if you're more of a visual kind of person, let's take a look at the graph. Okay, so let me hide the original one. Okay, so we can see here the domain is going to be any number, right? I can keep zooming out and zooming out, and I'll always get a number. I can always, like the value that I get is going to be really big. Excuse me. The value that I get is going to be really big, but there's no restriction on the input of my number, right? I can input any number that I want. So the domain is absolutely going to be the real numbers. Any kind of quadratic function, the input is always going to be the real numbers. Okay. However, the range, you can see that the range, I don't get any y values that are underneath that vertex. So there's a vertex of the quadratic. It's at -4, 5. So I'm not going to get anything underneath that. So all of my values are going to be above that. So my range is going to be all the values from +5 all the way up to infinity. So there's my domain and range. What do we have next? So how could I use the description of the translation of the function y equals x squared to determine the domain and the range of the image function? Okay. So let's think about that for a second. So by the way, this was part A. Bit of a mess here, but that's okay. This is part B. Let's do part C over here. So let's think about how we can use the description of the translation of the function y equals x squared to determine the domain and the range of the image function. So the domain and the range of y equals x squared is fairly straightforward. I'm hoping that we're familiar with the domain and the range of y equals x squared. Okay. At this point, like this is kind of more of like a grade 11 topic, right? Looking at the domain and the range of y equals x squared. The domain is going to be like, we can square any number. Take any number, you can always square it, right? There's no rules about squaring numbers. You can square, well, there's rules, but there's no rules that pertain to which numbers you are allowed to and which rules you aren't allowed to. You're always allowed to square a number. It can be like, it could be pi. You could square pi, nothing wrong with that. You could square -1, right? -1 squared is just +1. You could square any number you want. So the domain is unchanged here, right? And the range here, the range is just numbers greater than or equal to 0, right? So any kind of positive number or any number that's bigger or equal to 0 is going to be our range here, because when you square a number, it always becomes positive, right? Unless, of course, you're squaring 0, and 0 would just squared is 0. So the idea here is that we can shift the domain and the range along with the function. So the domain and range get shifted. They get shifted along with the function. Okay? The idea being that, okay, so the domain of y equals x squared is the set of real numbers. Okay? And it doesn't matter if I shift the real numbers to the left or to the right, it's still just going to be all the set of real numbers. So the domain of g of x is also R. Okay. And then the range of y equals x squared is, well, I include 0 and I go all the way up to infinity. And the range of g of x is that shifted up by 5, right? Because I move up by 5. So this is going to pertain to the domain, and this is going to pertain to the range, because the range is all the y values that I use, the up and down values. So if I've shifted my whole function up by 5 units, that means the range is going to get shifted along with it. So I'm gonna move all these values up by 5. So I'm gonna go 5 to infinity, right? And infinity plus 5, right? That's still gonna be infinity. So there we go. That's the idea of that question. Any thoughts or comments or questions about this? No? Okay. So my goal next is to end this video. If you're watching at home, we're going to have a bit of a work period. One of the things we're going to work on is question 10. Question 10 is a very similar type of question, but it's got a bit of a twist to it. So we're going to be working on this question here, and then we're also going to have some time to work on some of the previous problem sets. Okay, so I'll end the video here. Just over 20 minutes. Okay, I've been working really hard to keep these